So students are going to continue their practice of division. The first couple problems give you guidelines. So for problem 1, it tells you how many students are in the class. They're going to be in groups of no more than 7. And you want to make the fewest number of science lab groups so that these 37 students can work. It says draw an oval to make a group. So what you would do is you would draw the oval and you could put the group number in there. The dot inside represents the student in that group. You can either put the dots for your students or you can put the number. So if I wanted to make groups of 4, that would be fine too. So you're going to draw the number of students in each group. Have your students think about what the number model should be. The number model, remember, is the dividend, the total. The equal groups should be 7, and see what that does. For problem number 2, looking at a teacher buying pencils in bulk. So there's 4 new pencil boxes, having a total of 260 pencils. But she wants to make sure that each box has the same number. So she wants to box up her pencils. Again, think about the number model. This should be your dividend. This should be your divisor. So what I would ask students to do is practice the partial quotient, which we've done in class. So they're going to put 260, the dividend, underneath the division bracket, divide by 4. They're going to start by making 10 groups of 4 because they're equal groups. That would mean she could get 40 pencils into each. So they're going to keep going. So they're going to do groups of 10, groups of 20, groups of 30, groups of 40, groups of 50, groups of 60, and 70. They're going to try each of those groups of 4. All of this is extended fact multiplication. So they're looking to say, we know that we're putting them into 4 boxes, thinking of 2 times 4, thinking of 3 times 4, making it 10 times bigger. Once they figure out what the number is, the number of groups that they worked on and selected, whichever that one that is, they're going to put that outside here, that equal group. And then the product that they found over here is going to come underneath, and they're going to subtract that out. Then they're going to ask themselves the question again, how many more groups can she make with what we subtracted and have left of her pencils after the first bunch? On the back, students are going to continue with their division. They do need to show work here. So 592 into 8 teams. What I would suggest is having students, if they want to, they can do the opposite operation, the guess and check. So if they know there's 8 per team, guessing each of these answers to see if it gives them the total of 592 students. This will let them see the relationship between division and multiplication. They can take the number of competitions times the number of teams and see if that equals the number of students. They can also simply divide if that's easier for you or for them. The next one, they do need to also check the same method. They can divide or they can do guess and check. So the total number of birdhouses she can build means they can't use over 100 nails. So if they're going to use 8 nails per birdhouse and multiply by each choice, the number that is not over 100 would be what works. The other way to think about it is 100 divided by 8 equals the number of birdhouses she can build. And again, students would do this division problem the same way. How many equal groups of 8 can they use to build the birdhouse?